Hey guys, Mr. Backerberg here. In this video we're going to look at association, correlation, and linear modeling. When we're looking at a scatter plot of data, if those data points appear to cluster around a straight line, then we would say that there's a linear association between our variables. And if you think about drawing an oval around your data points, the narrower the oval, the stronger the association is with your data. So if we're comparing pictures A and B, there looks to be a positive relationship between our x and our y variables, but the oval in picture A is a lot narrower than the oval in picture B. So we would say that the picture in A has a stronger association between the x and the y variables. And something similar is happening in pictures D and E, except our line looks like it's going down, so we would say that this is a negative association. But the picture in D has a smaller oval than the picture in E, so we would say that this is a stronger negative association. Now, not every set of data points has a linear relationship. If we're looking at picture C, those data points are kind of all over the place and they're not appearing to gather in any certain location, so we would say that there's really no association there with that set of data. When our scatter plot appears to show a linear association, then we can measure both the strength and the direction of the association using something called the correlation coefficient. And we represent the correlation coefficient with an R value. And the correlation coefficient has a few properties. And the first property is that the R value, the correlation coefficient, is always a measure between -1 and +1. If there is a positive linear association, then we're going to have a positive R value. But if there's a negative linear association, then our R value will be negative. To check the strength of our linear association, we want to look at the absolute value of our R value. And the closer we get to 1, the stronger the relationship will be. And if there's a very weak or even no linear association, then our R value will be really close to 0. So in this example, we've got a company coming out with a new brand of cereal, and they're trying to figure out where they should price their cereal. So they do some tests at different price points, and they track how many boxes are sold in a week at that price point. And what we're going to try to do is come up with a model and then do a little predicting based on our model that we come up with. So what we're going to do is we're going to take all of this information and we're going to enter it into our calculator. We're going to take those prices and we're going to put it in list 1 in our calculator, and we're going to take the boxes sold and we're going to put that in list number 2. So I've got my calculator fired up here. The first thing I want to do before I get into entering in that data, we're going to look at doing some linear regression, and we want to check our correlation coefficient. But our calculators don't always show that when we're doing our linear regression. So what we need to do is make sure that our diagnostics are turned on before we actually do our linear regression. So right above your 0 button, it says catalog. So what I'm going to do is I'm going to hit second and then 0, and I'm going to arrow down until I get to where it says diagnostic on. And I'm going to pick that option by hitting enter, and then I'll hit enter to make sure that my diagnostics are turned on. Now I need to take that data that we were working with and I need to enter it into my lists. So I'm going to hit my stat button and we're going to edit our lists. We said we were going to put those prices in list 1, so I'm going to start typing that data in. And then in our list 2, we're going to enter in all of those sales. Now that I've got my data entered in there, I'm going to quit out of here. So I'm going to go second, quit. And then I want to come up with a linear model for this. So I'm going to go into Stat, and I'm going to arrow over to Calc. And we're going to do linear regression. So that's going to be option number 4 on our calculator. I'm going to hit enter. On my calculator, it asks me where I want to pull the information from. So my X's are in list 1, my Y's are in list 2, which is good. So I'm going to go down to calculate and hit enter. And what it'll do is it'll give me an A value, which if we notice in our equation, it's y equals ax plus b. So that A value is representing the slope of our line, and that B value on the end is the y-intercept of our line. And then down on the bottom, since we turned our diagnostics on, that R value in there is our correlation coefficient. And we said the closer we were to 1 or even -1, the stronger the relationship is. So our correlation coefficient is -0.98. So that's a pretty strong relationship because that number is close to 1. Now it's going to be a negative relationship since it's close to -1, meaning that as the price goes up, the number of sales is going to go down. Now what I'm going to do is go into my y equals screen, and I'm going to type in my linear equation with my A value plugged in for the slope and my B value plugged in for the y-intercept. And I'm going to graph this out in comparison to my data to get a visualization of what's happening. So in order to do that, I need to arrow up and turn my plot 1 on. Now when I hit graph, I'm not going to see much in there because I need to adjust my window. So I'm going to do zoom and go down to zoom stat, number 9 in there. So there's my line from my linear model, and there's all of my data points in there as well. Now with that correlation coefficient of -0.98, we said that there was going to be a really strong negative correlation. So we can see that all of our data points are really close to our line. But now, since we have this model, what we can do with this is a little bit of predicting. So we could predict sales for different price points, and because we've got a pretty strong correlation coefficient, we would assume that those would be good approximations for what the sales would actually be. So what I'm going to do is I'm going to go into my table. Now I'm going to make some adjustments on my table. And right now my X values are going up by 1. So that would be like a $1 increase. But I want to make that smaller since we're dealing with money. So I'm going to go second window. And instead of going up by 1 each time, maybe we go up by 20 cents each time. So I'm going to put in 0.20 to represent a 20-cent change. And now if I go back into my table, let's say we wanted to approximate our sales at $2. Then we would need to find an X value of 2. And we can approximate the sales to maybe be about 43,000 if we do a little rounding there. Or if we wanted to approximate our sales at $4 instead, then we can arrow down to get our X value of 4. And that one ends up being just a little bit more than 12,000 units sold. So the main thing in here is that we can take this data that we were given and we can build a linear model based on that, and then use that linear model to help us predict things so that we don't have to go through and test every single circumstance every time. That's going to be it for this video. Thanks for watching.